have coordinates for 3 points that are on the plane. So what I want to do is I want to find the equation of the plane that passes through those 3 points. So I want to find the equation of the plane based on those 3 points. So let's start identifying or defining some vectors here. So I'm going to go ahead and let's let R naught, well, I don't want to say equals it. Let's say be the position vector of the point P. Therefore, R naught is 3, -1, 1. And I'm going to let the vector A equal, 4 minus 3, 0 minus and minus 1, and 2 minus 1. I took the 4 minus 3, 0 minus and minus 1, 2 minus 1. So A is going to actually be equal to 1, 1, 1, which has, or with representation, I think I can fit that on there, yeah, with representation PQ. So now I'm going to let, say, vector B equal 6 minus 4, and that leaves me 3 minus 0 and 1 minus 2, which equals 2, 3, -1. And that, of course, is going to have representation QR. So basically, if I have these 3 points, P, Q, and R, what I did is I found vectors with these representations, PQ and QR. Now I could have just as easily gone PQ and PR. Basically, I'm just looking for these 2 vectors that I'm going to have on the plane is really all I'm doing here. Okay, so now I'm going to go ahead and let vector R equal XYZ. And vector R is going to be the position vector for an arbitrary point on the plane. This is necessary. We have to do this because that's how I get my X, Y, and Z into my equations. Okay, so I have these 2 vectors, A and B, that are on the plane. So with that, I know that A cross B is going to be a vector, and that's going to be orthogonal. To both A and B. That means A cross B is going to be normal to the plane. So let's go ahead and find that. A cross B is going to equal, let's see, I, J, K, and then I'm going to have 1, 1, 1, 2, 3, -1. And then that's going to give me, let's see, -1 minus 3I minus -1 minus 2J plus 3 minus 2K, which gives me the vector -4, 3, 1, which I'm going to call this vector n. It's normal to the plane. So what we really need is we need to solve n dot r minus r naught equals 0. The whole point behind finding this cross products, I know from the definition of a cross product, it ends up giving me a vector that's orthogonal to both of these vectors. So I needed that to get this orthogonal vector or this normal vector to the plane. So now all I have to do is simply go back and solve this now. And when I start that process off, what I'm going to have is negative 4, 3, 1 dot r minus r naught. Remember, r is this guy. That's my arbitrary point. So that's going to be x minus, let's see, r naught. So that's going to be 3, x minus 3, y minus a minus 1 plus 1, and z minus 1. And this has to be equal to 0. See, that's going to give me negative 4 times x minus 3 plus 3 times y plus 1 plus 1 times z minus 1 is equal to 0. So I'm going to have negative 4x plus 12 plus 3y plus 3 plus z minus 1 equals 0. And that's going to end up giving me the equation of my plane, which is negative 4x plus 3y plus z equals a negative 14. So that's the equation of the plane that passes through or has these 3 points lying on the plane.